Yo, 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 yo. Okay, so we're going to look at quadratics in standard form. So here is standard form of a quadratic function. So the difference with standard form is I can't pick out the vertex right away because it looks totally different. Okay, so standard form is when an example with numbers would be something like 2x squared plus 3x plus 5. So this b and a might be 1, so you might not have a number there, but those are the coefficients of x squared and x. Okay, so this would be a quadratic function written in standard form. So we're going to graph from this format instead of from vertex form. So first we want to figure out, well, what information does this C provide right here? So I have 3 different graphs for us to look at. Okay, and what I want to show you is that the C right here provides the y-intercept of each of these graphs. Okay, so whatever C is going to be your y-intercept. And that makes sense because if I were to plug in 0 for x, when x is 0 is the definition of the y-intercept. If I were to plug in 0 for x, well, 0 times anything is 0, plus 0 times anything is 0. So it's going to leave us left with C. So because this is the function, this is the graph of this function, the C is -1 because it crosses the y-axis at -1. +1 here because it crosses the y-axis at +1. And then -3 because it crosses the y-axis at -3. So the first thing we need to know is C provides us the y-intercept. So that's one piece of information from standard form. So if you need to even write that down in your original key term, you could write down y-intercept for C and draw an arrow there. Now, what we also want to figure out is we need to be able to find the vertex, because the vertex is always the most important part for when we're graphing quadratic functions. So we need to find the axis of symmetry in the vertex, because once you find the vertex, you know what the axis of symmetry is, because it's whatever the x value is. So if I have this function 2x squared plus 4x plus 3, I know my y-intercept is here at 3. So that's one point that's on this parabola. So that's nice. We can't really do much else with this. We can't use any information, but we at least know that's a point on this in this function. So if I want to find the vertex or the axis of symmetry, the x value of the vertex or the axis of symmetry is equal to this. Okay, so this is the formula that we use. So if we go back, the standard form is ax squared plus bx plus c. So I'm going to plug in the values for a and b into this formula to find the x value of the vertex. So if my function is 2x squared, so if it's 2x squared plus 4x plus 3, my a value is 2 and my b value is 4. So I can plug that in to this formula. So negative, and this is 4 over 2 times whatever a is. And a is 2, so I replace the a in the formula with the 2. B is 4, so I replace the b in the formula with the 4. And now I'm going to solve. Well, that's x equals the negatives in front of everything. That's 4 over 4, so that's x equals -1. So all we have figured out is the axis of symmetry is right here at -1, which means that somewhere on x is -1 is where the vertex is. I have to figure out what the y value is, though, so I know where my actual vertex is. So what I have to do is I have to take this x equals -1, and as some of you may have already guessed it, I have to plug it into my original function to figure out what the y value is. Because I know if I have f of x, well, if I have f of -1, that's 2 times -1 squared plus 4 times -1 plus 3. Well, now I actually have to solve. Okay, so you're going to have to solve for the vertex every single time. You're not just going to be able to just pick it out. So I have to do my exponent first. So -1 squared is +1. So that's 2 times 1 plus 4 times -1 is -4 plus 3. So that's 2 minus 4 plus 3, which is going to give me, let's see here, +1. So my vertex is at x is -1, y is +1. And so I'll use the teal to graph that -1, +1. So here's my vertex. Okay, so one thing that makes sense about the y-intercept being 3 and the vertex being here at -1, +1 is if we look here, the a value still provides you that rate of change for the first point. Very similar to what the a value was in the vertex form. So if we look here, this goes up 2/1, and my axis symmetry, we know it's on the other side as well. Now I've got to figure out what is my y value when x is 1 or when x is -3. So this part's also still the same as when we solved before in vertex form. So I actually do need to plug that in order to figure it out. So this is going to be 1 squared, which is 1 times 2, so that's 2 plus 4 plus 3, and that's going to give me 6, 9. So 1 is up, all the way up here. It's going to be up here like at 9, so there's my graph. So yes, it is more work than vertex form, 100%, because you have to do a lot more work just to find the vertex. And then after that, the work is actually pretty similar to vertex form. So it's just extra work to find that vertex. So here I have 2 graphs for you. I'll go over this first one with you, and then you guys will be able to try the second one. So this first one here, I know my y-intercept's at 4. I can plot that point. It looks like the a value is just 1, so that's nice. It's going to be a normal, like the parent function. It's not going to be wider or skinnier. It's going to be stretched out or compressed. So I know that it's -b over 2a. So the b is 2. So that's -2 over 2 times whatever a is. Well, a is 1. So that's -2 over 2, which is -1. So for the x value, again, or my axis of symmetry, we're at -1. So that's where the axis of symmetry is. So I can just draw a dashed line there on the axis of symmetry. So now that I know that of my vertex is -1, I got to figure out what the y value is. So I can plug in -1 into the function and solve. Ooh, I had a weird spaz there. And solve for the function. So it's going to be 1 plus -2 plus 4. Well, let's see here. That's 5, negative, so that's 3. So we're at -1, 3. And this is my axis of symmetry. I already have the y-intercept. And then now I can figure out when x is 1. It's going to give me 1 plus 2 plus 4, which is 7. There's my graph. Okay, now for this next one here, one thing I want to point out, I want you to try it on your own. My y-intercept's here at -4, but also we know it's going to be opening down because it is a negative a term right here. So it's automatically going to be opening down. So that's just one point of information I want to point out, piece of information I want to point out. So, but go ahead and solve, and let's see how you do. So pause it, graph it, try it, go. Okay, so again, vertex is -b over 2a, so that's negative, the b is 3 over 2 times 0.75. So I have to do 2 times 0.75, that's 1.5. And this is actually 2. So my vertex is negative. Oh no, I'm sorry, that's negative 0. That was almost a mistake, which is -1.5. Which is going to give me -2, but I have the negative in front, right? So 3 over -1.5 is -2, but the negative in front is now multiplying it all by negative, or that double negative here gives me +2 for the x value of my vertex. Whew, I almost made a big mistake there. All right, so now that I got +2 for my vertex, I know that that's where the axis of symmetry is. So then now I got to plug in +2 into my formula, and then I actually have to solve that from there to figure out what the y value is. So I have 2 squared times -0.75 plus 6 minus 4. I did plus 6. I should have done the math, but that's 3 times 2 when I plug in 2. So 2 squared is 4. So I have -0.75 times +4, which is going to give me, let's see here, -3. So I have -3 plus 6 minus 4. So -3 plus 6 is 3 minus 4 is negative 1. So my vertex is at positive 2, negative 1. So here's my vertex. Now I know my slope from here, and this is kind of nice. I don't have to do any extra math. This worked out really well. Because my slope is negative 0. That's negative 0.75 over 1 on both sides. And then it looks like I have my next point here at negative 4. And so it's got to be on this side right here. So it's a little bit wider. Just a little bit. Okay. Finally, you might be asked to compare the vertex of each function when we're looking at two different things. So here I have two different fountains, fountain A and fountain B. Okay, we have the fountain A information here. We have fountain B information right here. We want to figure out which vertex, we want to compare the vertexes and figure out which fountain gets higher. So fountain B, you should be able to pick out the vertex right away because it's its highest point and it's where we change direction. So the vertex here is at negative 410. So for fountain B, the height, the highest point is the y value. So the maximum is 10. So now I just want to compare that with fountain A and figure out which one gets higher. It's not the y-intercept. The y-intercept has nothing to do with the vertex. So I actually have to work out the vertex by doing negative b over 2a. So that's negative, and that's 2 over 2 times negative 1. So a is negative 1 here. That's going to give me 2 over negative 2, which is negative 1. But I have that negative in front. That's going to make it positive 1. So the vertex for this one is going to be positive 1. And now I got to plug that in. Okay. Now, whoops, sorry. Now, here's something I have to be very careful of, is that when I plug in positive 1, so this is negative x squared. So when I plug this as negative, I'm plugging it in parentheses. So that's going to be plus 2x plus 8. So that's plus 2 times 1 plus 8. This is still positive 1 squared. Positive 1 squared is positive 1, but then I'm multiplying it by that negative 1a value. So that's why this is going to end up being a negative 1. 1 squared is positive 1, and then positive 1 times negative 1 is negative 1. Plus 2 plus 8, and that's going to give me a total of 9. So this fountain gets to 9 feet. This one gets to 10 feet. So fountain B reaches the greater height. Okay, that's all I got for you guys. The biggest thing to remember on this one is that you have to use the formula for the axis of symmetry and for the vertex, and it's remembering this formula, okay? And then also that once you get this answer, it only gives you the x value, so then you have to plug in that x value to figure out what your y value is. Okay, so just make sure we don't forget this formula. And yes, it's more work, I get it, but it's one of those things where this is just a different form that we have to know, and that we'll actually see this form probably more often later on. So, or not probably, we will 100% see this form more often later on. So, all right, guys, thanks for watching. If you have any questions, let me know. Cordias out.